Hey, second period. So we are going to take some notes on section 1.4, which is going to be solving absolute value equations. Solving those absolute value equations. So the cool thing about these videos are that you can pause them, replay them, do whatever you need to, but you do need to write down everything that I write down on the screen. So let's first start about what is absolute value. Well, you've probably seen it in the past. The absolute value is the distance from 0. And what I mean by that is, well, if we have the absolute value of -4, that is 4 units from 0, meaning the absolute value of -4 is 4. But also, the absolute value of +4 is equal to 4. So when we think about absolute value, they're always going to be positive. Now that doesn't necessarily mean the equation always equals positive, but the absolute value itself is always going to equal a positive number. And these little bars right here, those are the absolute value symbols, right? So absolute value of -4 is 4. So once again, just as another example, absolute value of -6 times 2 is going to be the absolute value of -12, which equals to a +12, because -12 is 12 units away from 0. Okay, so those are the basics of absolute value, but we, of course, are going to be solving absolute value equations. And we need some steps with those. So, step number 1 is that you are going to isolate the absolute value as much as possible. And we'll get back to that as much as possible in a little bit, but we're definitely going to go ahead, we're going to isolate it. So you want to make sure that it's all by itself, absolute value equals something. Then once it's isolated, you're going to set up two equations. Set up two equations. And we're going to have one that equals the positive value and one that equals the negative value. And what I mean by that is that you could have the absolute value of x is equal to 8. So there's two different options here for x. Is that we can have x is equal to 8 because the absolute value of 8 is 8, but you also have the option that x is equal to -8. So you want to make sure that you have the positive and the negative version of whatever we're going to go on inside those absolute value signs. So once you set up your two equations, we're then going to solve them. So don't make sure that you're solving both your equations. And then the really important step, and go ahead and put a little star next to it, is that you need to go ahead, you need to check your work. And particularly when your x is outside your absolute value. So check your work, solutions, to make sure that they work with your equation. We're going to get to kind of those, we're going to work with the meaty steps here, then we'll check on the bottom. So example 1, we're going to have the absolute value of x minus 4 is equal to 6. So if I look up here at my steps here, I've isolated the absolute value. My absolute value is isolated, meaning that it has the absolute value of this equals a number. Okay, now I'm moving on to step 2. What I'm going to ask you to do is actually draw two little arrows from your absolute value signs to remind yourself that you're going to have x minus 4 is equal to 6 and x minus 4 is equal to -6. And as a reminder, we're doing that because this in here can be the positive version or this in here can be the negative version, right? They both will give you 6 as an absolute value. So then we're going to solve, and we're going to use those inverse operations. So I'm going to add 4 to both sides. X is equal to 10. We're going to add 4 to both sides on this side. This is a little bit different. X is equal to -2. And then I'm going to go back, and I'm just going to check our work here. So I'm going to plug in 10. So 10 minus 4, that's 6. The absolute value of 6 is 6. That works for us. Go ahead and give it a little box there. And then my other one here is negative 2. So negative 2 minus 4, that's negative 6. The absolute value of negative 6 is 6. This guy also works. I'm going to go ahead and give it a box. All right, so for the most part, you are going to have two solutions. You are going to have two solutions for the most part. There's a few little things that we do later on where we will go ahead and cross off the solution. For example, 2. You're now going to have 2 times the absolute value of 3x minus 9 minus 10 equals 2. All right, so these little absolute value bars, you cannot cross them, meaning you cannot distribute right here. So what you actually need to do is that you need to isolate this 3x minus 9. And we're going to isolate that 3x minus 9 by using our inverse operations. So I'm going to add 10 to both sides. Negative 10 plus 10 goes away, gives me 0. 2 times the absolute value of 3x minus 9 is equal to 12. And then, once again, we're still trying to isolate this absolute value right here. So you're going to divide by 2, and you get the absolute value of 3x minus 9 is equal to 6. Okay, now we're isolated. This is the part where we isolated. We did all that work to get there. We isolated the absolute value. So now we're going to go ahead, we're going to break down these equations. So 3x minus 9 is equal to 6 because inside here we can either equal to a positive 6 or inside there 3x minus 9 can equal to a negative 6. And now it's time to do our inverse operation. So add 9, 3x is equal to 15. Divide by 3, and we get that x is equal to 5. There's one of our solutions. We now need to do the other side or the other equation. Remember, solve both of them. So add 9, 3x is equal to 3, divide by 3, and we get x is equal to 1. It's always a really good idea to go back up to your beginning equation and check. So 3 times 5 is 15 minus 9 goes ahead and gives us 6. All right, 2 times 6 is 12 minus 10. That works. I'll give this guy a box. And for time's sake, right now I'm going to tell you that the other one works as well. But always a good idea to go ahead and check those solutions. Okay, so those are our basic absolute value ones. But they get a little bit trickier when we have two absolute values. So remember when I said we're going to isolate it as much as possible? Well, sometimes that looks a little tricky. So I'm going to have the absolute value of 2x plus 5 is equal to 3 times the absolute value of x minus 4. All right, and this is one of those situations where, once again, this absolute value right here, this absolute value of 2x plus 5, is isolated as much as possible. So we're going to go ahead, we're going to split up this equation, and we're going to have 2x plus 5 is equal to, now I'm also going to go ahead and I'm going to break down this guy because I'm going to make this the positive version, 3 times x minus 4. But then remember, you also have that other guy over here. So you're going to have 2x plus 5 is equal to, we're now going to make this side of our equation over here equal negative 3. And we're going to say x minus 4. So once we break down those absolute value signs, we're going to make them into parentheses. Okay, we can solve this. We have 2x plus 5 is equal to distribute 3x minus 12. All right, I don't know about you, but I think that it's a lot easier right here to take this 2x and move it to the other side to stay positive. If you wanted to minus your 3x, you also could do that. 2x, leaving me with a 5 is equal to x minus 12. I'm going to add 12 to get my value of x, and I get 17 is equal to x. Okay, so there's one of my values. Now we're also going to go ahead, we're going to check it on the other side. Distribute that negative 3. Watch your negatives, please. Negative 3x, and hopefully you said positive 12. All right, and this one I'm actually going to go ahead, I'm going to add 3x, and I like to keep those coefficients positive. That's why I'm adding 3x. Plus 5 is equal to 12. Now I can subtract 5, and I get 5x is equal to 7. Now, this is one of those funky ones that when I divide, you're going to say, you can't divide 7 by 5, so you're just going to keep it as a fraction right there. So your two answers here are going to be x is equal to 7 over 5, and x is equal to 17. Now, that one's a little bit tricky, but the things that I want to go ahead and point out about this is that you're isolating as much as you can, and then once you break down the right side of your equation, you're going to just make your leading coefficient negative and then distribute. All right, let's go ahead and let's jump into our last equation. The last equation for these notes. Example 4. We're going to have the absolute value of 2x plus 12 is equal to 4x. All right, this one is isolated, so we get to go ahead, we get to break down these absolute value bars right away. Meaning that 2x plus 12 is equal to 4x, and 2x plus 12 is equal to negative 4x. We are going to use inverse operations. Again, I'm going to take the less of those x and I'm going to subtract them. So I'm going to subtract 2x. That leaves me with 12 is equal to 2x. Divide by 2. And we get 6 is equal to x. So there's one of my solutions, but hold on one second because we're going to have to go back and check it. And then on the other equation, I'm going to add, we are going to minus 2x minus 2x. Now the reason I did that is because we want to combine our x's together and knock it to 0. So negative 6x. Now divide by negative 6, and we get negative 2 is equal to x. Okay, and this is the key part of this, is that because we have an x on the outside of our absolute value sign, we really need to check that our answers work. So we're going to go ahead, we're going to start with 6. So we have the absolute value of 2 times 6 plus 12 is equal to 4 times 6. All right, just quickly doing this, we have 2 times 6, that's 12. So we have the absolute value of 24 is equal to 24. Yep, 24 is equal to 24. That one works. You can go ahead and give yourself a box. So x equals 6 is a solution. Now, checking our negative 2, we have 2 times negative 2 plus 12 is equal to 4 times negative 2. And you might see the problem already is that we have negative 4 plus 12, that's 8. The absolute value of 8 is not equal to negative 8, so this does not work. And this is actually what we call an extraneous solution, meaning that even though we did all of our work and we did it properly, we introduced a solution that doesn't work. So the only one that works for this solution or this equation is x is equal to 6. So that's the only one that you can keep. You have to cross off this x equals negative 2. So this one only has one solution that works for you. Now, as a reminder, if you ever get to a point where you have an absolute value equation, such as 2x minus 5 is equal to negative 100, so distance can't be negative, cannot be negative, meaning that this is no solution. No solution. So same thing for like if you had the absolute value of x plus 3 is equal to negative 14, no solution. So if you ever have it isolated there, that won't work. All right, second period, I will see you Monday for any questions. Please email me if you need some help, and I will see you soon.